Okay, as a reminder, this is a review. We're not going to stop for videos. We're not going to do any of the extras. We're just going to get through the material. It's meant to be a quick hit review of the material. And so this should not be the first time you've been exposed to this. We're going to jump in here and we're going to look at chapter 5 in management and technical operation. This is page 163 and 214 in your book. Some of the discussion topics that we'll be talking about here explain the aspects of operating within the cloud, explain DevOps in the cloud environments, and then the financial planning of cloud resources. So, in our introduction on page 164, it goes in and it talks about some of the changes that we've seen specifically around some of our cloud products that we would run on prem. But then it quickly jumps into talking about the difference between thick versus thin clients. And these are terms that kind of came around in the early to mid 90s. And it was mainly around when we went from our mainframe apps to where we were signing into the mainframe from our terminals. And they were referred to as dumb terminals or thin clients. And so we had a machine that really was not that powerful. And it was so this is where this concept of thin client came from. But then in the 90s, our machines started getting a little bit better. And so we started doing some of the processing on the machine side. So even though we had systems that were running out there, at this point, we were running into mid range type of systems. So we would have these really big Linux, or not Linux at the time, Unix machines, and we would sign into them, and some of that processing would be handled by the machine that we was in front of us, and some of it was handled out there. And so we kind of went through a period of time where we were running this, and one of the reasons we were doing this is our networking, our internet connections had not caught up yet. And so we were still kind of battling dial up. So there was a need to do the processing and the computing functions in different areas in order to make it seem still okay and the speed be okay for our applications. But then when our internet speed started coming up to speed, so cable modems started coming out and people started paying for high speed internet. And now it's expected that almost everywhere and everybody has internet of some kind of high speed internet. And those that don't probably have some kind of satellite solution or something. But now we've kind of gone back from having our thick clients or our fat clients to back to where it doesn't really matter what the speed of the computer is in front of you. You can be running a Chromebook. You could be running a MacBook Air. You can even run some from your phone, but all of the processing is actually going on the computer that's out there. And of course, we refer to that as the cloud. Now, you guys have been studying this long enough. You know there's no magic to it. It's running on a machine that is owned and managed by somebody else. In this case, we're talking Amazon, Microsoft, Google, Oracle, IBM, their cloud. So we now that whole conversation of the thick versus thin client is kind of going away again. We can run things on a thin client or we can run things on a really fast client. It doesn't matter because most of the processing is going on out there. So then that also brings up the conversation around our management console. So we can access the management console. Our management console is where we sign into the CSP and we create virtual machines, we create networking, we do our work, and we're doing it all from a console that we are signing into. It may feel like it's on the computer in front of us, but of course, we all know that it's not in front of us. It's actually just a console view of what's going on in our management console that's out there on our cloud service provider. And then that also brings up our conversation around command line interface and serve software development kits. So CLI is when you access your cloud environment from a command line interface. Several reasons that we would want to do that. We would, if we're going to automate functions and we're going to want to go, um, we want to do things in the same way, very, very fast, then we would access it through a command line. Our management console, we're going to point and click. We can do things. It's more like being in a nice little Windows environment, but command line is saying, I already know what I'm going to do. So go out, create this, do this, create this networking to this. open up this, you have all of the steps running in a script so that you can get to it from your command line. And Software Development Kit, kind of the same thing, except you are using a some kind of software development kit like um, Python, Node.js, .NET. You're using a programming language in order to interface with your cloud environment. So here are some of the aspects of operating within the cloud. So, quote, the cloud opens up a new world. We still need all the historical concepts, terminology, but now we're adding a layer for the cloud. So, yes, we're sort of just moving on prem data centers to commercial clouds, but there's more. And we're taking advantage of global infrastructure. So, some of the things we're going to talk about here is our data management, availability, disposable resources, monitoring and visibility, and optimization. Now, one of the reasons I put sort of on this slide is we're not just trying to move things out of the data centers. That is a huge reason to do it. And as you know, we pay only for what we use. There's lots of cost savings, but it also opens up a brand new world. There's lots of things that we can do in the cloud that we never could have done in our own data centers. So that's why I say sort of, but just know that removing our data centers is not the only goal of cloud. There's also other reasons. So let's first talk about our data management. So data management. So our most valuable asset is our data. There's phrases out there like data is the new gold. But if you think about what you've seen in your lifetime, I remember when I was younger and they were talking about that we were in the information technology, the information age. And they were talking about how valuable data was. I have to admit that when I heard that when I was a kid, I was thinking, how valuable can data be? Valuable, data is not going to be as valuable as oil or a renewable resource and then think back even farther in history when you think when iron, that was what was, the big, they were in the iron age. But really and truly, we've seen it over the last 25 years how valuable data is. There's more money spent on collecting people's data and information about them than just about anything else. And then also, if you think about your own life, what are the most valuable things you own? There's probably some things in your home that you would hate if something happened to it. But if you think about your data, if your pictures, your music, the things that you have that are really just data on a computer have really become the most important things that you have. Unless you have some family heirloom or something, most of us, if you said, would you rather lose everything in your house or all of your pictures? We'd think, well, that stinks, but I'd rather lose everything in my house, all of my physical things, that I want to make sure that I have access to my pictures. So that right there proves to you that we're in that era where data is one of the most valuable assets. So what do we do? You know, to make sure that we take care of our very valuable assets. We have replication. This means that our data is not just one place, it's being backed up somewhere else. And so if you make an update or add to it here, it's going to go somewhere else. That way, if the data center goes down or something happens to a disk, you always have access to that. And then that kind of goes into the locality conversation. Where is the data? Is the data near the user? And then, of course, then we talk about our backup. And so our backup says, I want the data that I'm using right now located near me, but I want the backup to be very, very far from me in case there's a natural disaster. In case something happens to one area of the country, we don't lose our data. So we think of this on a personal level, but also companies think of it in the exact same way. We want to replicate our data. We want to know where it is. We need it close for our users. But if we're in a backup or a disaster recovery scenario, we need it very, very far away. So here, replication, that's our data availability. We're not going to click on these links, but if you want to, don't forget that you have access to these slides and you can watch these videos, but we have availability zones. So whenever we're thinking of our data centers out there for Amazon, Microsoft, Google, the data centers are the same thing as what we would call an availability zone. So we've talked about how they're usually between 10 to 30 miles from each other. And that's because the speed of light dictates how far away we can put our data centers. We want them as far away as possible, but we also don't want there to be any latency at all. So somewhere in the neighborhood of 10 to 30 miles is our limitation of the speed of light. We can have a machine sitting right next to each other and they can work and pass data back and forth, or we can pick it up at the speed of light, put it about 30 miles away, and it still goes just as fast as if they were right next to each other. But if we start getting much farther than that, even the speed of light will notice some kind of latency. You would never notice it in just looking at a couple of files. But if you're talking about thousands and thousands of files moving back and forth, the speed of light, you would eventually have enough latency in there to stack up to cause you some kind of trouble. So our availability zones are data centers, and then we have multiple of these availability zones inside a region. And a region is a geographic location within the country. So we would have those, and those are hundreds and hundreds of miles apart. And so, you can look in here and look into AWS and Azure. I believe AWS has over 30, I want to say 31 regions in the world. Microsoft has they have over 60. And so these regions all have multiple data centers within them working. So then there's two types here. We have synchronous, and that's where data is written to multiple locations at one time. Then we have asynchronous, where data is written at specified times and has an RPO, or a recovery point objective. All right, and we already talked a little bit about locality, but the location or proximity. So the speed of the internet is still limited by the speed of light. So locality refers to the location where your data is in the CSP's infrastructure. And then backup, and this has to do a lot with our disaster and recovery. You plan for failure, malicious or a natural disaster. So some kind of failure, and as long as if you plan for failure, you won't be disappointed. So we have our databases that we plan for, the hardware itself, and then our network. And so what we do here is we have these snapshots, and these are rolling back or returning to a VM to the state of the snapshot. And creating new virtual machine from a snapshot is an effective copy of the original server, and then copying the snapshot to the object storage to be used for recovery at a later date. So, lots and lots of different conversations. Remember, there's so many use cases. We can't learn everything, and there's no just one right way to do things. But in short, you want to make sure that your database is backed up by the minute, and you even want to be able to recover from them. And I think I've mentioned before that back there's a time when you could have said, um, hey, engineering team, we lost our database. So everybody needs to go back and do all the work that they did yesterday. But that's no longer the case. Now we need our backups to be much, much better and faster. So we might say, hey, you just lost the last thing you were working on in the last 2 or 3 seconds, but we're not going to ask somebody to go back 5 minutes, 10 minutes, or an hour, or especially a day. We're going to keep our backups running live so that we can fail over and our users don't even have to know that there's an issue. And then, of course, our hardware. When we say hardware, we are talking about virtual machines that are running out there on the environment. And so it's not a hardware, but it's a machine. And so we want to be able to back those up. And so when we take snapshots, a lot of times we take those daily. And with a daily snapshot, it's really meant for a very bad recovery. You hope that you don't have to restore from that backup. You might want to look yesterday's backup and do something with it or pull a file from it or something, but you're not planning on backing up. You're not planning on restoring from a backup yesterday, but worst case scenario, you are able to do that. So some other conversations that we have when we're talking about those backups, how often do we back up? And then how many of those backups do we keep? We don't want to keep one that's 6 months old. That would do us no good whatsoever. So when you're determining What is that RPO? What makes the most sense for your backup? Those are the types of conversations that you will have. And then the last one we talked about there was availability. So one of the largest benefits of using the cloud, CSPs offer a scale that would be difficult and costly for anyone to implement on their own. So when I'm talking about Amazon having 31 regions, Microsoft having over 60 regions, if you were trying to do that on your own, what that would mean is that for every zone that you're using, you would need to have a data center, at least two or three in every region, every city that you're trying to run your work from. Well, if you're just, even if you were a large company, this can be a drain. This is an expense, and it's hard to do. But if you're in the cloud right now, think how easy it is. Like I have things running here. Let's say I have a bunch of stuff running in one of the regions and one of the zones, and everything's working great. So I decide, hey, I'm going to go ahead and expand my business, and I'm going to move over to two or three other areas within the country. And then after a while, that starts going good. And I say, you know what? I'm going to expand my operations overseas. Well, when you're in the cloud, that's just a click of a button. You go up, you make sure that you're able to operate within that region, you create another region there, and you are going. There might be a little bit different in cost depending on where you are, but you would be able to run your business across most countries. Of course, here in the U.S., you wouldn't be able to run in a communist country. That would be one of the exceptions. There might be others, and then there's also areas because of different tax structures when you sign in and you're spinning up environments, you'll find that some service is more expensive if you run it in a certain area more so than it is in another area. So anyway, what I'm getting at here is doing this in the cloud is easy. Doing this on your own, very expensive. So right now, if I wanted to deploy something in Germany, I could do it in the next 15 to 20 minutes. If I wanted to if I didn't have the cloud and I was trying to do that same thing, I would have to travel to Germany. I would have to seek out what the rules were, what the laws were. I would have to purchase a building, hire people there to build my data center. So, as you can imagine, that would be a 2 or 3 year ordeal. And now we're talking about doing it all within 15 minutes. Here's some of the things on the regions within our AWS and Azure. So AWS has the Northern Virginia region, Ohio, Northern California, Oregon, and Central. And then Azure has even more. They have, a couple in Virginia, um, California, Washington, Toronto, Iowa, Illinois, Texas, Wyoming, Quebec. And I know there's even more than that on the Azure side. Now, keep in mind, if you look at that list, that doesn't automatically mean that Azure's better. It just means that Microsoft's been around longer and they have more data centers. But depending on where you're wanting to run, both AWS and Azure are going to suit your purposes just fine. And then we have geo redundancy. That's the next level up. Offers cross-regional availability. Services are replicated between regions to offer greater availability. Unfortunately, physics and the speed of light rear their ugly heads and place limits on how quickly cloud services are in sync. So what that's saying is, right now, if I build a server and I want to fail over to another server, I'm probably going to do it within the same region because that's how I could do it and make it invisible to the user. It would be nice if I could run something in Virginia and then fell over within a minute or two and be operating over in the western side of the country, like Oregon. And you can, but it's not instant. And so the people that were hitting the server in Virginia, of course, would notice a lag if all of a sudden they were filled over to the other side of the country. So, you have to make good cloud decisions on how you run things. But it is nice to know that you can run your disaster recovery systems thousands and thousands of miles apart. And what you do is like even your databases are always loading up the last transaction and throwing them over to the other place. So if you had a natural disaster and the right half of the country lost all power, You would be able to go pick up and be running in a different data center, and you would still, all of your data would be there and it would be up and running. It's just that you wouldn't want to do that as a normal failover. You don't even want to do that in a disaster situation. All right, here's a little picture of our um, cloud delivery network. So, let's see, the blue, where there's a lot more of these, are edge locations. And then right here are the purple shows multiple. And then the orange there are your regions. So if you're looking here, this is the Amazon. There's the regions. There's one in South America. There's two right here in this part of the country, one over here. Then you can look at Europe. But all of these edge locations are out here for other use. All right, some more on the aspects of operating within the cloud. Disposable resources. Recall going to the cloud, no upfront cost. So we can build duplicate environments in minutes. This allows bootstrapping, gold image, and hybrid. So again, these are disposable resources when you're building in the cloud. And this is great because back in the day when you ordered equipment, we've already talked about how long it would take to place it. But then when that equipment was getting end of life, you still had to deal with it. And a lot of times we would just keep using it. We'd be using equipment that no longer satisfied our needs, but it was just too expensive to replace. And but with cloud, it's disposable and it's great. You spin up a server, you run it. All of a sudden, you need to go bigger. You spin up a bigger one, you migrate your workloads over to it, and you trash the other one, and it goes away. Boom. There's nothing to throw away. There's nothing there. It was just a soft server anyway. So that's another great thing about these cloud resources is they're all disposable. So then the bootstrapping, that's taking an already tested and verified virtual machine image and applying the post-deployment process after the initial start. This can also be called hardening. But what you do is you take a server, you spin up the one that was good, but then you always have to go grab the latest patch set and you'll make sure that it's up to par when you spin one up. Gold image, taking an already tested and verified virtual machine image and customizing and deploying. So a lot of times what we do, this term actually came around with laptops. That's the first time I ever heard of a gold image. But when you would have work for a big company and they would want to put out an image, they'd say, hey, let's go with the one image. And it was an image that would work on all laptops. And if you were fancy, you might have a different one for desktops. And it cuts out a lot of trouble because then you don't have different versions of software running around, different versions of operating system. You go with the one image. And then, well, as with most things, you have hybrid, which is a cross between two things, and in this case, a cross between bootstrapping and gold image. You perform any complex or advanced deployments through gold image, but anything that's relatively easy to script, you put in the post deployment launch. All right, and now we're talking about monitoring and visibility. So compare this to what we've traditionally done in an on-prem data center. Multiple teams at multiple locations and multiple response organizations. But now think what is available in the cloud. You have alerts and logging all in one place. So you can go in to your console and you can say on every machine, when it gets to a certain level, I need to get an email. I need to be alerted. I need it to text. So we can do that across the board. We have much more control of all of our equipment, not like the old days when every machine was running independently and we didn't necessarily have that. I mean, we did what we could. We'd say, okay, all machines deployed have to have a certain in um, certain piece of software out there that talks back and lets us know when there's a problem, but it's much cleaner and you feel more secure about it in a cloud world. So then, I've talked about the alerts. Remember when we talked about alerts, we kind of talked about the history of alerts. At one time, the alerts would tell us there was a problem. Then after a while, we can use our alerts to say, you know what, let the system know there's a problem. And if it's this type of problem, we're going to automatically fix that. So alerts, billing, storage, compute, and networking are threshold based. In other words, with a resource, um, When resource A reaches threshold of X, an alert is generated. And then we also have logging. So this is recording of events and actions that have occurred against an asset. So logging is critical for an organization that utilizes technology. Working in IT, you have to handle situations where someone has asked what happened after something goes sideways. So logs are going to be the primary source of information on past events. So whenever you start digging into the actual CSPs and you learn the the processes and the applications that they all have the ability to see what's happening right now. And then they also have logging. And that's where you know what happened an hour ago, where you know what happened um, 30 days ago. Usually they default at about 90 days, but even then you can put them into storage. You can pull those logs and throw them somewhere. And if you've ever worked in IT, you've seen this. If you haven't, I'm going to explain it to you. But every application that runs out there has certain logging events. So somebody signs in, it logs it. Jeff signed in. And then if I went out and I changed something in the environment, it'll have a log entry. Jeff changed blank in the environment. So you do this because sometimes you're going back through those logs trying to figure out what happened. So let's say that one day we're looking at our systems and at 3 o'clock in the afternoon, something started happening. Some error started occurring. You can go back to the logs and follow along and say, what happened at 3 o'clock in the afternoon? And let's even say 3 o'clock in the afternoon 2 weeks ago. And there might be an entry in there. Developer blank did blank. And so you can go back in and say, wait a minute, why did everything start breaking after this point? So you go back in, you look at the log, you go track down, you might look at change records, or you might actually talk to the person's name that was associated with that time entry and say, what happened at this time? Well, let's say you find out that a developer put new code out on at this exact point in time, and that's when everything started breaking. Well, then it's easy. You say, okay, can you fix this problem? If you can't, roll back that change. So logs can help you immensely. As a matter of fact, I would say there'd be so many issues that got by that if you didn't have the logs, it would be next to impossible to support the system. So again, that was the little conversation around your alerts and logging. All right, now we're looking at optimization. So optimization, cloud offers agility that's not realized on-prem. So this is when we get really, really into what is so good about the cloud. Of course, what's already good about the cloud? It's cheaper if you know what you're doing. It's faster. You get things closer to your customers. There's so many things that's better about the cloud. But then we're going to get really into the virtualization and what's better here, auto scaling. So auto scaling is where we keep an eye on resources. And if they start to get used too much, then we can do things, we can add resources to the virtual machine so we can scale up, or we can duplicate machines and scale out. So this is what's called horizontal scaling. That's where you add resources to one server, or vertical scaling. I'm sorry, verticals where you add resources up. And then horizontal is where you duplicate systems. So this is where we get into that whole conversation around, we start out talking about servers and then we start talking about containerization. But going back to just a few slides ago, alerting. The first thing we do, my system is in trouble. Send me an email. That's the first thing you do. Then after a while, you say, I'm tired of getting that email or that text message at 3 o'clock in the morning. Why don't I put some automation around this? So instead of having someone sign in and scale out, now we just do an automatic thing. So this helps us in two ways. This helps us with our performance, but it also, on the reverse side, helps us with our cost. So we run with the bare minimum of resources. And let's just say, for example, we have 5 people on one server and everything's good. And then a sixth person gets on the server, and that's when it starts to get maxed out. So now we know that every time there's 6 people on, let's scale up and let's add another server. So in the morning, we start out, I have one server running. By 9 o'clock in the morning, I have 10 people have joined in. So then we duplicate it. Now we have two servers running. And then a little bit later, another 10 people join in. So we add another server. And then at the end of the day, whenever we've had less than 5 people on a server, we start removing servers so that we can scale back down. So that helps us with our cost, yet helps with our performance. And then another concept here, besides auto scaling, is right sizing. So this is another thing that cloud allows us to do that we never could do back before the cloud. And I've talked about this one before. When we'd have a big application that was running, so we would go purchase a server, and we didn't just purchase a server that would meet our needs today. We purchased a server that was going to meet our needs 5 years down the road. So we would go spend the money up front, deploy the server, and it would be running, and then we would be watching it. And we always hoped that our server was running at, like, 50% utilization, maybe 75% utilization. But if it ever got up to 95% utilization, we were scared to death. We're like, uh-oh, we're about to be in trouble. So we'd get in and we'd be adding memory. We'd be stopping old processes. We would do whatever it took to get that utilization back down to an acceptable layer. In cloud, we want to spin up and we want those things to run as heavily utilized as possible. So 95% doesn't scare us anymore. We run a server and we're like, all right, we're getting our money's worth. That thing's running at 95%. We don't ever want a server that's running at 50%. That means we provision the server twice as powerful as we needed. And we want to use auto scaling to scale up more servers as we need, or to scale vertically and add resources as we need. So this allows us to do things that save lots and lots of money. All right. And then now we're kind of entering into a new section here, and we're going to talk about DevOps. So, DevOps is the combination of cultural philosophies, practices, and tools that increase an organization's ability to deliver applications and services at high velocity, evolving and improving products at faster pace than organizations using traditional software development and infrastructure management processes. This speed enables organization to better serve their customer and compete more effectively in the marketplace. So in our DevOps pipeline, we talk about things such as development, build, test, and release. So let's jump over here and look at some of our tools. So we have our source tools like Bitbucket. Let me see if okay. This is a slide I'm still working on. You can look over here to the right, but we're talking about what tools that we utilize. So our source tools, we have things like GitHub, Apache, and Subversion. So I'm going to go through these individually, one at a time here. And so source tools are ways that we keep our source code. So remember, we're talking about DevOps. We were talking about software development. This is different than what we've been talking about, because usually when we're talking about cloud, we're talking about infrastructure. So now, not all organizations are completely divided, but most of the groups that I've been with, you kind of keep your developers on one side of the wall and your infrastructure on the other side. It's just kind of how it's traditionally been. But I will say with cloud, things are kind of different. People are more working together, and resources are able to handle both the infrastructure side and the development side. But what we're looking at here on this slide, just talking about development. And there's a chance some people go out and they become software developers and they never once think about the infrastructure. They don't want to think about the infrastructure. They want to write code. So anyway, those are the people we're talking about now. So you have your source code, like you have your GitHub. So when you see something that's called like a Git system, this is where you have your source code. So you would get your source code, and that's where that word comes from. And as a matter of fact, the opposite of whenever you pull your code out and when you check it back in, you use a command called put. So these old source control systems, they would use on a Git, and you would work on this piece of code. And then whenever you got ready to check it in, you would put it back, and you would either put it back with changes, or you would, put it back with no changes, and stop the lock. But it's a way that you pulled out the chunks of code that you were going to work on for a specific purpose and then put it back. Then we have our build tools. These are things like Jenkins and Microsoft Visual Studio. So the build tools is where you pull out the code using your source code, and then you make changes. And then when you check it back in, you use the build tool to pull that source code together and you build what's called your executable or binary, depending on what language and what things you've worked on. You check it back in and you have this, you build a package, and that package is what you deploy. I'm not going to bore you to death with all the details of why, but I mean, there's lots of reasons. You'd have system variables in each, you would have all these different reasons that you need to build it. So you pull the code, edit the code, check it back in, build a package, and then with that package, that's where you deploy it from development environment to test environment to production environment. And there might be 4 or 5 other environments in there as well, but for the most part, let's just keep it simple and talk about the three: development, test, production. And then you also have your testing tools like Selenium, Pester, Vagrant, and there are lots and lots of different testing tools. And of course, nowadays, not only do you have your testing tools for making sure that your environment is doing what you want it to do, but you also have all these security testing and you have these penetration tests and you do lots and lots of different things with the testing tools. So that list there of those three, that doesn't even scratch the surface. There are lots and lots of different testing tools. And then you have your release tools. Our book here lists Chef and Puppet. Um, that's those are, I don't know if Chef and Puppet necessarily belong there, but the book feels like it does. So I'm going to go along with them. They definitely know what they're doing. But with our release tools, this is like kind of like our pipeline management. This is how we handle things from the beginning stage all the way to the end stage of when we're checking code out, we're doing it, and we're editing it, we're checking it back in, we build the package, we test it, and then we deploy it on. So again, I'm the reason I started this slide, I just haven't finished it over here, is because there's a bigger conversation to be had here. But in short, this is a good thing, and it helps you as it's learning about the infrastructure side. It helps you understand what it looks like from the developer side. All right, the next section we're going to talk about here is our provisioning. So we're going to need resources to work along this pipeline. We are going to need to create these in the cloud or provision. To build on what we've learned in a previous section, we should build immutable and disposable resources. So that's a quote out of the book there. One of the things that you want to make sure that you do at all times is infrastructure as code. This will help you so much. So infrastructure as code is a way for us to, as we are building resources, if you use one of the tools that's inside the CSP, it will do this for you automatically. So if you set everything up correctly. So if you're out there pointing and clicking and adding resources and doing things, it will also update your infrastructure as code. But you want to make sure that you have that set up ahead of time. And the reason you want your infrastructure as code is you want to be able to take this code and deploy it into a different environment and spin up all the resources. So there are many, many use cases as to why you would want to do this. So the ones that come to my mind is, let's say that we're working on an environment and it's a really big environment and it has multiple nodes and we're building it. And so we use our infrastructure as code. And then all of a sudden funding gets cut to our project. Well, we need to stop spending money today. Well, if you've already built your code in infrastructure as code, that's an easy thing to do. You stop all resources and anything that you can't, like, storage and stuff that you can't stop paying for, you can delete and pull and just stop your environment. You can even go as far as destroy the account, tell Amazon that you're done with the account, tell Microsoft, I no longer want this enrollment, and stop it. And if you have your infrastructure as code, that would fit on a thumb drive. You have it. It's something that you have in your possession. And then a week later, they decide, or a month later, or a year later, they decide to put funding back onto your project. You plug that drive in, you go get a brand new account, you deploy your infrastructure as code, boom, you're back up and running. Another really good use case for wanting to do this, let's say that I am building an environment with a tool that I am trying to sell. So then I go out and I'm going to a brand new account today. So I go talk to this new company and I say, hey, I have this software and it does this. And they say, hey, that might be something we're interested in. You say, okay, let me spin you up a brand new account. Now let me deploy all the resources for this and then throw the application right on top of it and say, okay, this is yours. I'm deploying this in the cloud. Here's your sign in. This belongs to you, and it is only going to last a certain amount of time. And then you have a timer in there where after a week, a month, whatever you want to do, it automatically stops everybody from signing in. It removes all the resources and it goes away. So, that's another use case of what is really good about infrastructure as code. But I mean, there are so many. As a matter of fact, I mean, just working in a normal environment and working with people that are, you're working with a customer and they want to make changes. You want to make sure that you always have the infrastructure as code lined up. So if you go a little deeper into this in your book on page 182, you'll learn about the imperative and declarative approach, the different tools. Amazon Web Services has this really cool tool called CloudFormation. It splits in two screens. You can go up and move things and add things to the GUI, and you can see the code change down at the bottom. And it helps you build out. And then you can go in and change the code at the bottom, and you can see that the GUI changes at the top. So it's a really cool little product. And then Azure has something very similar. I just haven't used it as much as Azure Resource Manager. Other tools for infrastructure as code is Terraform, Chef, and Puppet. These are bigger than the CSPs. These are tools that will work with any CSP. You can work within the tools that are just AWS, just Azure, or you can use Terraform and Chef and Puppet, and it's infrastructure as code. You build it, and it will work in any environment. And then you also have templates like your type, your image ID, block device, and mappings. And then you can do stack deployments like WordPress, multi-site, MS Windows Server, Active Directory, and Magento. Okay, and the next thing we're going to talk about here is something called continuous integration and continuous delivery. This is, I don't want to say new, it's somewhat new to me, um, as I've always been a part of programs like this, but really, I've only seen it in writing over the last 4 or 5 years. That could just be my limited exposure to it. But I see it's becoming a bigger item and one that people are asking for more. When I say people, I mean large organizations when we're doing, you know, when we're responding to RFIs and RFQs. But it's really a hot topic lately. CI/CD has become synonymous with DevOps. So, in short, where application updates and changes are constantly being released, we're building on our previous topics to deliver this concept of CI/CD. So to be efficient with this continuous change, we need disposable resources, infrastructure as code, auto scaling, and we need our infrastructure to be predictable, reliable, scalable, and changeable. So we'll break down continuous integration from the continuous delivery. So really what this is saying is dev test to UAT to prod. That's what it looks like to the business. But what it means to you as an IT professional, it's saying that we are always building, always deploying new functionality, good functionality to our customer. So it's taking little bitty chunks of code, updating it in a circular, progressive motion. It's an agile type of methodology. It's saying that we're going to constantly put out better code and constant updates and try not to ever get it to where we have to back something out. So again, just think of it as another agile, but it's more around the DevOps side. And you go from development to test to user acceptance test to prod. and then you start over. And there are different time frames on this, but a lot of times people work in sprints and they consider like a 2 week as a sprint. So every 2 weeks, we're deploying code that should have all the functionality you had before. It should be tested. It shouldn't break anything, but it fixes all of the top priorities of the business unit from the previous 2 weeks. All right, and then the next thing we're going to look at is testing and QA environment. So this is just some vocabulary that you need to know about your testing and QA environments. So that includes sandboxing, and so this is a completely separate environment. It's beta and development, and so a lot of times when you're putting out a new product, this is what you'll show everybody where the sandbox environment is, and it allows them to go out and practice and play around in what is the new environment. Another word here is load testing. So this is one of the hardest types of testings to execute in the real world. So what is the proper load to test? How do you simulate the load with real users? What other load testing besides user load do we need to test? So like the database load. So load testing is something that's a little bit easier in the cloud because you can really crank up some things to really try to beat up an environment and see how it's going to react to 1,000 users, 2,000 users. But something I've mentioned before, if you do a really good job of auto scaling and creating your environment in a way that will self heal, you want to be careful because you don't want to turn on too much load testing because you might end up just spending a lot of money without actually testing the load of your environment. If you do want to do some load testing, you want to trim down your auto scaling and make sure that you're just testing what happens with a group of servers as they really, really get um, worked on. But like I said, if you have a self-healing environment, you could find yourself spending thousands and thousands of dollars and never actually tacking out the environment. And then the final word here is regression testing. This validates that new features don't impact production. This is a very important one and one that I've seen large organizations mess up, but you always have to make sure that you have some automated regression testing because you don't want to put out code that fixes one thing but then causes another issue somewhere else. All right, and now we're going to talk a little bit about provisioning and our configuration management. So some extra vocab here. Orchestration is the glue or the coordination between automation tasks. Orchestration will free up resources, both digital and human, so they can perform other tasks. Orchestration strives to make automation efficient and manageable. Managed automation is also great and necessary for DevOps, but unmanaged automation will lead to issues of who, what, and when. And automation, the technique, method, or system of operating or controlling processes by highly automatic means, reducing human error, human intervention to a minimum. So, automation has always been key in IT. As a matter of fact, 25 years ago, I would have said automation is really the point of IT. But now, I don't know if I would necessarily say that's true, but automation has become synonymous with your infrastructure technology organizations because everything that they can automate, they're going to automate. And it's not just to make things cheaper, it's also to make sure that there's no human error. So anytime you do something in an automated fashion, you're reducing that human intervention to a minimum in order to make sure that you don't do anything that causes you don't leave any chance for human error. All right, and then next thing is in our provisioning, upgrades and patching, and API integration. So I'm just kind of barely touching on these, but these are some vocab that you need to know. And I keep saying that because I mean, yes, in certain areas of IT, you're going to really need to do a deep dive and really understand these things. For the point of this certification in this class, you could be a manager of some groups. You may not have your hands on keyboard in order to be in here, but you for sure have to understand how these things. You have to understand what they are and what it means. So upgrades and patching, we've talked about this before. Every system requires monthly upgrades and patching. So you get the patch list depending on the operating system, and then you throw it out in the test environment, and then a week or two later, you put it in the production environment. And there's never going to be a month that goes by that you don't have some kind of patch that you have to apply for your operating system, applications, and databases. And then, of course, API integration. This is your application program interface, um, and there's more in your book on that. But these are the things that we have to keep in mind whenever we're keeping these systems up to date. All right, starting a new subject here, financial planning of cloud resources. How can we ensure total cost of ownership is cheaper when we move to the cloud? We need to consider some of the following. So first thing I'm going to tell you is when you see TCO, total cost of ownership, what this is it's a comparison of the non-cloud environment and your cloud environment. So total cost of ownership. Whenever you say total cost of ownership, that means leave nothing out. So let's say I have my environment running in a data center, and I'm telling you, oh, I can run a server for $250 a month. It just takes, we've already paid for the server, and it sits there in the building and it runs, and I've put a monitor on it, and I know that's all the electricity it uses and all the processing and everything. So it just runs for blank amount. That's not the total cost of ownership. Total cost of ownership says, how much does it cost to keep the building going? Do you own the building? Do you have to pay taxes on the building? How much does it cost for electricity? How much does it cost to have somebody sit in the front lobby and protect the building? What is the security cost? Do you have somebody that walks around and maintains the data center? Do you have to keep the building? Does somebody come in and clean the building? All of those things, total cost. So that way, it's a fair comparison when you're looking at total cost of ownership in my old environment and total cost of ownership in the cloud environment. Because of course, let's say I've said that server could run for $250 a month, and I'm trying to show you that I could buy you a server in a cloud environment, but it costs $500 a month. Well, that server that you're telling me is only $200 or $300 a month is actually much, much more. So anyway, I'm just trying to really stress what total cost of ownership is, or TCO, because if you see a test question on it, that'll make it make more sense. You go, oh, total cost of ownership. I'm comparing what it costs to run my server in my own environment versus what it would cost to run one over in the cloud environment. So then to read the bullets here, CSPs offer several different types of storage. What are the use cases for the different types of storage? Do we need to use commercial software that needs to be licensed? First of all, let's go back to that storage one. That's another one, total cost of ownership. In your environment, it's the total cost of the disk. In a cloud, it's only the part of the disk that you used. So you pay for what you use. And do we use commercial software that needs to be licensed? This is where you look at total cost of ownership. What does it cost you to license that software and use it in your own environment versus what does it cost if I'm going to use the marketplace in AWS or the marketplace in Azure? Um, do we have a department that wants to move everything to the cloud? How can we track expenses and pass along charges to the department? So again, I went really deep into that, but talking total cost of ownership. What does that mean? Every penny that you spend to run an environment. All right, three main categories. We've kind of touched on these already, but storage, network, and compute. Okay, so our storage, we have three types. This is the second time you've seen this. You've seen this in chapter 2. But there's different types of storage. Depending on the CSP, you kind of have to talk about them in a little bit different verbiage. But if you're talking object storage, block storage, or file storage, those are synonymous. Those are in your own data center or in a CSP, regardless. Object. So object level storage, storage for the internet, object level storage. This is AWS's flagship product in 2006. And you could say that this is what really started the cloud was when Amazon put Simple Storage Service, or S3, out there for purchase. If you don't forget to go in there and play around, we've already done this once, so we're not going to do it here in the review, but you can go look at the different pricing models and you can see that storage is dirt cheap. But it's all the stuff that you put on top of that that makes your storage option more valuable. So don't get discouraged when you look at that and say, well, that's so cheap. Why am I paying such and such for Office 365? Or why am I paying so much more for Google? It's because you're getting all of the other services on top of it. So that's object. Remember, object is object level storage. If it's an object, if it's something that can contain itself, like a music file, a document, a picture file, anything with a that is a file with a with a dot and then an extension after it is an object that you can put out in object level storage. Then you have blocks. So these have sectors on a hard drive. And so when you back them up, you only back up the blocks that change. So we talked about that more in chapter 2. That comes in like your solid state drive or your hard disk drive, which is like a spinning drive. And so you can pay more money for some good solid state drives or a little bit less money for spinning drives, depending on what you need it for. And again, when you think of blocks, think of like databases. That's where you store it because at the end of the day, it takes a look at what blocks changed. Not all of them did. It only backs up the blocks that change. So it's a better way to keep a lot of data. And then the last one here, file, multiple endpoints can write to the same destination at the same time. So one of your best examples of that or something you've seen is like Google Drive. We could all be looking at the same Google Drive from our computer, and we can add that as a drive on our computer so it looks like a hard drive, even though it's really not on our computer. It's out there being used and shared by all of us. All right. And then the next thing we're going to talk about here in our financial planning is the network. So, how do we stop? Network is kind of like how do we stop bad traffic? How do we allow good traffic in and out in each device? So, you can do as much studying as we've done here on network. As a matter of fact, a lot more. There are people that focus on this, and network is a study that you could go very, very deep in. But we're going to be very high level here and we're going to say that the network is what we use to allow the traffic that we want to allow and to stop the traffic that we do not want to stop, that we do not want to allow. And then the next one we're going to talk about here is compute. So lots and lots of test cases on compute. There are different classes of compute. We have our general type, which is good for day-to-day operations. CPU optimized, these for like CPU intensive workloads like video processing. Um, Memory optimized, more intensive workloads like large databases, GPU accelerated, GPU enabled applications like AI, and then storage optimized for storage intensive workloads like data warehousing and such. All right, a little bit more on compute. So we have chargebacks, that's spin up, shut down, only pay for what you use. So again, when you're talking about compute and you're talking about the cost of compute, um, there's you would want to go in and look at the use cases. You're not going to be expected to know this, but I know that my company has put a lot of work into this to figure out how many hours a day a compute resource needs to be turned up versus turned off in order to make it worth it for you to um, decide to have a startup and shut down of your compute resources versus going out and purchasing a reserved instance, a different conversation that we'll have later. Um, but there's different things that you look at in the compute on how you're being charged for it to make you know what you should do as an organization. Resource tagging. It's a tagging strategy. So this is when you spin up resources, you can tag them. You can use them for different purposes. You can tag them for development, prod, test. You can tag them for um, application. You could tag them for different teams, and you can use those tags when you're running financial reports to determine who is paying for what. But again, that comes with a tagging strategy, and it has to be followed by the organization. If the organization fails to do a good job of doing their tagging strategy, then it would make it very difficult for a financial person to go in and to split cost up by tagging. But it can be used to split out costs, and it helps determine what application/area a resource belongs. Next thing, maintenance. So on-prem, 10 to 25% of the base upfront technology. On-prem technology eventually has to be disposed of. We kind of talked about that earlier. With cloud, you just shut it down and delete it. You're never running on old equipment, never using bad memory. The days of this outage or hardware has changed. So what I'm saying there is when you're back in the 80s and 90s, when you would have an outage, you would get on a call with a bunch of people, try to figure out what caused the outage. And it usually came down to either somebody changed something in the environment or there was a hardware issue. And in the early to mid 2000s, there was a lot of trouble with these old servers because in the 90s, people were going out and purchasing memory sticks and they were very cheap. They were putting them in machines. So then 10 years later, they all seem to be failing around the same time. So you'd be running along, applications going great, and then something would mess up. You get a bunch of people on a call, you'd be there all night long, and you'd finally get people in that would say, you know what, I believe it's bad memory. So then you'd have to go exchange the memory, start everything up, test it, would take hours, and then boom, everything would be okay. Well, now the good news is we're never running on old equipment. Whenever you're in the cloud, you're always running on good new equipment and you're never running on the same equipment you were yesterday. We understand a hypervisor layer now. It's not a physical machine. It is, we're running in a virtualized environment out there. So we're not running with old bad memory. Amazon, Microsoft, Google, they're ensuring that we are running on really good equipment without bad things. And if something needs to be failed over, you hit a switch, boom, you fail it over. You're on a completely new piece of what we're going to call hardware, even though we all know it's not necessarily hardware. And if you're having the same problem, well, that means it's probably something somebody changed in the environment. So that's what I mean there on that last line. Is it hardware? Or is it something that changed in the environment? Now we usually know it's something that changed in the environment. We don't have those kind of hardware problems anymore. And you'd be surprised how much time that saves organizations knowing that it's not hardware, because you don't even have to have those conversations. You don't have to run those tests. You just fail it over quickly. Same issue. It means something changed. You go check the change log. You see what changed. You roll back to change. You're up and going. Last thing I'll say on that is I spent years of my life where I would be woken up late at night, early in the morning, always having problems like that. And in the last 7 years, I've had 3 phone calls where there was something wrong and we failed over, or we checked the change record, we changed it, and it was over in 10, 15 minutes. There were times I'd spent 6 or 7 hours chasing down what the problem is. Since I've moved into the cloud, less than an hour total time over the last 7 years has been spent trying to figure out what went wrong. All right, a few things here on the instances. So pay as you go. Pay as you go is when you sign into the cloud service providers management console and you spin up a resource, you pay for what you use. That's pay as you go. Then we have reserved instances. This is where um, you pay a little bit, you pay up front for a 1 year or 3 year commitment, and you pay upfront, partial upfront, or no upfront, and you can save up to about 72% of the cost of your instance if you pay for it and make a 1 or 3 year commitment to the service provider. Then we have spot instances. Kind of went light on this because we've talked about this before, but spot instances are instances that whenever they drop to a certain level, you'll pay like 92% discount for the instance and you can run some compute jobs. The deal is with a compute job, you have to, with a spot instance, you need to have your workload where it can stop on a 2 minute notice. So it's only good for small little jobs that like batch processing. And it can't be anything too important because you have these jobs stored up out there and you're only going to get your jobs run whenever those compute instances are available. So that's a spot instance. All right, and then here we're talking about our reserved instances. So it's a 1 year or 3 year, all up front, partial up front. our no upfront. And then there we have our spot instances. But like I said, it's really 92%, but it's available at a 90% discount compared to on-demand prices. You can use spot instances for various stateless, fault tolerant, and flexible applications such as big data, containerized workloads, CI CD, web servers, high performance computing, and other test and development workloads. I have personally never been able to find a workload that I could run within a spot instance, but there are lots and lots of examples out there. Um, some people bring up genome testing. And then another one is like running batch jobs. So, if I want to, the ones I think of are like in telecom, where back in the day we had all these telecom stores out there. They would submit their workloads at night, and then the next day, those are at night after everybody went home, those workloads would start running at night and they would process all these jobs. So it would be things like new service, process that job, get these um, make sure that somebody goes out to this site and hooks this up, send that out to the workforce management system, next job, and it would run through and do all of these jobs. So those are the types of jobs that you could save some money running spot instances. All right, and then the next thing we're going to talk about here, just kind of it's all within the finance section. That's why these are all together. But we're going to talk about the different licensing types. So we have free for use, um, pay for use, and then bring your own licenses. So we won't spend a lot of time talking about it here, but free for use just means that it's free for you to use for a certain amount of time or some reason. And then there's pay for use that puts rules around how you can use it, how many users you can use, how many can use it at one time. There's different licensing models around that. And then the BYOL, bring your own license. What that means is prior to being in the cloud, you were paying a certain level and you didn't want to lose that. So you reach out to that vendor and you say, hey, I'm going to run your software that I've been running in my own environment for years. I'm going to run it with this many machines in this way, and I want to bring my own license with me. And so they'll let you do that. Right. And then license quantity. Licensing is a complex topic, oftentimes vendor specific. For example, you'll need to know what you need a license for every running instance that you have deployed. The key part is running and powered on. It doesn't matter if the instance is not handling production traffic or workload. So again, that's just there's lots. Every piece of software has its own style and type of licensing. Um, and so it all depends on what the software is. All right. So in this chapter, we covered a lot from the aspects of the operating in the cloud to introduce our DevOps and explain the financial impact of operating in the cloud. And then we introduced the data management and how we keep our data available and consistent. Then we introduced the infrastructure of CSPs and the breakdown of zones, regions, geo-redundant locations. Cloud has enabled the concept of immutable infrastructure or disposable resources. This is where cloud resources are treated as commodities, not permanent fixtures. We showed the importance of alerts and logging to keep an eye on your cloud resources. They allow you to know what's going on and set up self-healing resources. The self-healing resource enables through auto scaling. And before any organization decides to make a leap into the cloud, they need to take a closer look at their on-premise resources to perform right size analysis. Again, the reason they say that, you don't want to go out and build the same thing you have in your data center, or you're going to spend twice as much. You want to make sure that you're doing smart things with your cloud resources, whether that's starting a startup shutdown schedule or reserved instances. And you want to make sure that you are right sizing so that you want your server running at 95%. You don't want your server running at 50% because all that means you're spending more money than you need to. And then we introduce our DevOps and in general, how you can use tools provided by the CSPs and how to provision resources in the cloud and utilize code to define our infrastructure. There's an important concept of imperative versus declarative when defining infrastructure and resources. We discuss CI and CD and how they are central to every need to perform as part of the CI/CD pipeline. Automation and orchestration are the cornerstones that glue that make the CI/CD work. And essentially what that's saying is we develop a circular type of timeline where we're always introducing new features that correct things, try not to ever introduce anything that's going to hurt anything, and a continuous improvement as it goes through the pipeline. And then finally, we discussed the financial side. There was a lot of information on that financial side, and I do not get discouraged by that. Take a look at the sections. It's just when you're talking about the finances, you kind of have to review everything we've learned. So everything we've talked about and everything we've learned got pushed into that finance section because you have to have financial conversations around all of your things: networking, um, compute, storage, databases, services. They all come with their own style of financial conversation. So again, if that seemed a little overwhelming there at the end, don't let it be. Just go back through it and look at it section by section, and just know that you're reviewing them. You're talking about the same information that we talked about in all the other chapters. We're just talking about the finance side of it. All right, let's run through our exam essentials. Know about data availability and the part replication plays. So data availability is the concept of making and keeping data available to users and applications. Replication is the process of storing data in multiple locations to provide other means of data availability in one location is no longer available. There are two different kinds of replication: synchronous and asynchronous. Synchronous replication keeps data synced in real time. Asynchronous replication replicates data on the time determined by the RTO and RPO. I forgot to give my little disclaimer here. Don't forget that the exam essentials are our flashcards. It's a great way for us to see if we understand all the facts. And if we don't, then we know where we need to focus a little more time studying. So these are really great things for multiple reasons. And I'll put this in the video I make where I go through these. What I like about it is you might feel like you've learned 500 things, but actually, if you look at the exam essentials, you're going to see that you've learned about 150 pieces of information. And it makes it where it's a little more, it gives you an opportunity to see where you stand. And even though you read these chapters and you run into things that maybe you don't know or feel like you need to study more, if you're looking at the exam essentials, you're saying, okay, I know 100 of the 140 things. Now I need to go learn the other 40 things. So we'll talk more about that later. Know what locality means and understand the benefit that cloud offers. Data locality is the impact distance has on data access to the end user. So essentially what this is saying is you want the location, you want it close to your users when they're using it. Now for a disaster recovery type situation, you want the locality to be very far from your users because you don't want to be where if there was a flood, if there was a natural disaster, that you wouldn't want that to impact your users. Know the part backups play in restoring data or services. Backing up is the process of copying data to a medium that can be restored in the event that the data is lost or compromised. Backup processes in the cloud are similar to backup processes performed on premise. Virtualized infrastructures. Snapshots are executed and copied to the object storage on a schedule that is aligned with the required RTO and RPO. Know the difference between zones and regions. A zone is either a data center or a collection of data centers within a CSP's infrastructure. The CSP's infrastructure within a zone is within a close proximity to each other and offer high bandwidth, low latency to facilitate synchronous replication. Regions are local collections of zones within a CSP's infrastructure. Regions are named after the location around the globe. For instance, US East, Canada, US Central, and US East. So in short there, remember regions are geographical locations and availability zones are multiple data centers inside those geographic locations. Know what geo-redundancy is and the part of a CDN. Geo-redundancy is the process of replicating data services between regions. Geo-redundancy has two main goals: keeping data and services running if a region becomes unavailable, and offering a closer locality to end users. CDN is distributed in multiple regions. It's a delivery network of data to facilitate the locality. Remember, CDN is the edge location. We have 30 regions within the country, but we have like 600 content delivery networks within the country because it is a one directional, put the data out there right next to the customer so that they have access to it. We know what disposable resources are in the shift and deployment processes. Having disposable resources is the concept of treating infrastructure that supports data access as immutable or unchangeable. If you have new versions of the applications or OS, then do not deploy them on the current infrastructure. Deploy new infrastructure with the updates and changes. There are two techniques for deploying infrastructure more quickly: bootstrapping and golden image. Bootstrapping is having the development of infrastructure include customization and installation through a scripting process. Golden image means having the customization and installation be part of the image that is deployed and already present at the moment of deployment. Know the importance of monitoring and visibility. Monitoring and visibility provide insight and notify when events occur in the cloud. Alerts monitor and produce actions based on the properties of the deployed infrastructure. For instance, storage, compute, and networking. Logging is the recording of events or actions that occur either in the cloud or on the resource in the cloud. Logging the cloud is already present and needs to be configured. Logging on resources will require additional setup. Know the process and benefit of auto scaling. Auto scaling is one of the coolest features that's the largest benefit of moving resources to the cloud. You can set parameters that will scale both in and out based on resource health and usage. The cloud can be self-healing when events occur that would normally have a negative impact. Know the importance of right sizing in the cloud. The biggest reason for cloud initiatives to fail is cost overrun. That's a very important concept and one that large organizations make the mistake of all the time. So you want to make sure that any project you're a part of is not guilty of this. So this is due to organizations performing lift and shift strategies. They move everything to the cloud. The cost model between cloud and on-premise is in direct conflict and not compatible. Right sizing is the process of performing an analysis of on-premise resources and providing them correctly sized resources in the cloud. Like I say, for years and years and years, IT resources have been trained to think we want to run at about 50 to 75% utilization. That is no longer the case in the cloud. You're saying, I'm paying for it, I want to use it. So I want to run a server it's sitting at about 95% utilization. We don't consider ourselves in trouble until we hit like the 99%. Then we want to do something about it. Know the DevOps processes and mindset. DevOps is change in historical deployment process. The CLAIMS acronym is a good thing to remember to help understand culture, automation, lean, measurement, sharing. DevOps tries to turn down the silos that exist in most organizations. The process needs to be iterative and have feedback loop. So I will tell you that this is in the exam essentials, did not make it into any of the slides or anything that I discussed, but we do want to talk about the CALMS acronym. That is something that you might see again. So that's the culture, automation, lean, measurement, and sharing. It's one of the agile methodologies and something that's kind of core into our current development lives. Know the benefits of infrastructure as code, IAC. IAC makes your infrastructure be defined as code. This allows the use of tools used in the development process for infrastructure. The IAC allows for imperative defining of resources instead of declarative. You define what the resources should be, not what the resources are. There are templates available online that have complex infrastructure deployments and can be tailored for your needs. Know what the CI/CD is and how it relates to DevOps. That is the continuous improvement, continuous delivery. It's an implementation of the DevOps process. It uses the tools from software deployment to execute the 4 steps of application deployment: dev, build, test, release. Know various testing processes. Sandboxing is the process of testing changes in the environment that is close to production but cannot impact the production environment. Load testing is the process of testing new code under circumstances that are close to real world use. For example, underload. Regression testing is the process of testing changes through detailed and documented processes that won't reintroduce previous discovered issues. Know the process and tools used for configuration management. Automation is the method of controlling a process in such a way as to limit or even remove any human intervention. This removal of human error aspect is also makes the process repeatable. Orchestration is the coordination between multiple automation techniques. Orchestration brings all the pieces and parts to the DevOps process together with logging, monitoring, and auditing of the entire process. Know the importance of API in the cloud. Every action, whether performed as part of the orchestration or viewing logs, is in a management console is the API call. This means there are no difference between web tools, CLI tools, or SDKs. They all perform in the same way. So what that's saying is that whether you do it in the console or you do it by the command line interface or you do it by the software development kit, you could go back in and do it with any one of those, and it's done to the cloud environment. And so your SDK is going to know this, your CLI is going to know what it looks like in your management console. So you make the change in one of them, it's going to show up in the others. Know the difference in examples of cost using storage, network, and compute. Storage costs depend on the type, object, block, or file. Object storage costs are based on the transfer and access, including replication. Block storage costs are based on the type and the speed of the storage. File storage costs are based on the transfer and access. All three have costs associated with them and the amount of storage used. Network costs are based on the amount of data transferred in and out of the CPU's infrastructure or the CSP's infrastructure. Compute costs are based on the resources, for instance, CPU, RAM provision. So a lot of information there on one slide, but it's just talking about the costing of your big three: compute, storage, and infrastructure, and network. Know what chargebacks and tagging are. So chargebacks are the process of assigning cost resources to either individuals or departments that are responsible for the resources. Tagging is used to correctly assign properties to resources to identify who's responsible for a resource. So again, every resource created can have up to like 50 tags, and then you can use those tags however you want. You can tag it by the environment, you can tag it by the owner, you can tag it by the application. Lots and lots of use cases as to why you want to make sure that you have a really good tagging strategy. Know the 3 types of instances and their differences. So by default, any instance is an on-demand instance type. This is pay-as-you-go model. You pay only for the resources and the amount of time that it's on. Reserved instance is a type of prepay model. You pay for the resource upfront, even if you're not actively using the instances. And then spot instances are instances that are renting reserved instances not currently being used. On-demand is the most expensive option. So I know that if you take the Amazon Cloud Practitioner or the Microsoft Cloud, it's not practitioner, I can't think of what they're called. You do have questions in there about the different, which one's more expensive. I don't think that this certification is going to ask you that, but just you should be able to tell that anyway. On demand is the most expensive, but sometimes it's the best. Reserved instances are the next expensive. If you pay all up front, that's the cheapest, but you have to come up with money all up front. You pay partial up front, a little bit different. And then if you pay no upfront, a little bit more expensive. So you can mentally see how that works. And then, of course, spot, dirt cheap, but you have to have the right kind of workload for them to work. Know the different licensing types and the impact they have on cloud licensing. So there's free for use license that have become synonymous with open source. There's software that can be used freely without having to pay for any of the licensing fee. Pay for use which becomes synonymous with commercial software or software that you must pay a fee to use. And then use of either in the cloud is available, but pay for use license is impacted. Use of commercial software in the cloud is dependent on the software vendor and must be treated individually. So don't forget, you can create a virtual machine. You can install software just like you had it running on a machine that was in your data center, or you can pay for it through the marketplaces, different ways that you can pay for these. All right, so this is the review. So you've already read the chapter. Now we're going to go through and do our written lab. So blank replication keeps data in sync between two or more locations in accordance with the RPO and RTO. Asynchronous. CSP's infrastructure is broken into logical units called blank, which offer high bandwidth and low latency connectivity. Zones. Blank is the process of scripting or writing code that will configure and customize any cloud resource at the point of deployment. Bootstrapping. Setting up parameters and resources that will grow or shrink with demand is called autoscaling. Software-defined networking is an example of infrastructure as code, or IAC. Blank testing is where new application code is tested against past bugs. Regression. Creating a system that is able to perform the same steps in a repeatable and consistent manner is called automation. Blank is underlying technology in all management tools for CSPs. Blank is the underlying technology in all management tools for CSPs. It's the API, the application programming interface. Their blank are the cheapest instance types one can utilize in the cloud. Spot. Blank is the technique for being able to use your already purchased license on a cloud resource. BYOL, or bring your own license.